Okay, that's the last one we're looking at right there. It's physically pretty large, so but I can't read the size. Oh, it's right here. Looks like 25. 25. Oh, I probably got something that can do that. What is this thing doing anyway? Well, I think it's grounded on this end. I think that's, let's check that. Yeah. So that looks like a bypass capacitor on the output tube. Is that the output tube there? I think that is the output tube right there. So that's the cathode bypass. That'd be the cathode resistor right there, that fairly high wattage resistor. So it's good to change this guy out. It looks okay to look at it, but and before I do that, let's make sure I've got one. 25 at 40 volts. 25 at 40 volts. Here's 50 at 100 volts. I don't think it matters if we go bigger on there. What's this one? This one is 47 at 25 volts. And that's a little low, isn't it? These are great big guys. That's way too big. Hey, how about this one? So I got one there that's a little big. 50 at 100 volts. Let me just check another couple spots here. That's what we would put in. 50 microfarads at 100 volts. Yeah, it's a bypass capacitor. And the reason they didn't put a 50 in when they built the set was it would have cost 8 cents more. That'll do the trick though. We don't have to use the same ground point. But we can if we want. Let's check this one. Let's see what we got here. There's a good look at my my meter. Okay, we'll put this on 20 megohms full scale. Well, you're seeing that number upside down, by the way. It's around, it's coming up on 2 megohms. That's not very good, is it? I think it is leaky. Where'd you go? Down there. Okay, so we'll put in this nice big one here. Nice long lead wire on it. We could ground it somewhere else if we wanted. Why not ground it right there? It's a good idea. Anybody see where my pliers are? Yes, here they are. Now, if a capacitor, an output capacitor, is weak, doesn't have much capacity, more and more the signal will drop on the oh, that's interesting. I didn't finish this. Lucky me. I guess when I got interrupted at some point I must have forgot to finish this. Anyway, I was saying the capacitor on the cathode resistors, if it gets weak, then the output will get weak. Okay, I guess that's okay. There we go. Should be able to solder that up quite nicely. Missed. Okay, that was two at once there. And I'm doing this under low light conditions because I think it gives better camera lighting, but I won't be able to do this always. Let's take a look at that one. now. Need a little more light there. Yeah, he needs a little more solder. There we go. So that's all the capacitors in here now, well, except for a couple of mica ones, which are normally very reliable. Okay, so there's the two mica ones there. There's no other capacitors in there. So it'll be interesting to see if now the radio actually comes to life. What I get, I think I gave it 50-50 odds of that. So why don't we give that a try? Okay, a little safety check. Everything looks to be okay. Let's put the eye this way so I can see it, because that may start working. It's a 6 US. Just so you can see, that's what we changed out of it. Okay, ready on the power. And we'll now apply the power under restriction. We got a little bit of noise right away out of the speaker. Oh, volumes are probably turned right up. Pretty good hum in it now. Oh, something just quit. Don't like that. That's not the kind of thing you want to hear a radio do. Hum for a bit and then make a little pop and stop. That's not my idea of a good time. Okay, so that could be almost anything. That could be a tube. That could be another component which is now experiencing voltage it hasn't for a while. Going ouch. Let's poke around here and see what kind of voltages we find. Nothing on the tube. Okay, so you can see the meter here. I'm on the 1000-volt scale. First thing we'll check is B+. It's a little higher now, 304. Wow, it's 304 with the power restricted. Almost 300 on the other side of this big resistor. 300 there. $15 dropping on the cathode resistor. I'm going to check that. 0 on the other side of that. $300 there. And we're getting voltage like we're supposed to everywhere we're supposed to get it. Did I speak too soon? It's a tube with no voltage on it. Check first. Voltmeter's working. Here we go again. Pin 1, pin 2, pin 3, pin 4, pin 5, dumb meter will time out right in the middle of you using it. Pin 5. Okay, I think I'm seeing a short circuit here. Let's cut the power. We'll test now to see if that was a short circuit, where I've allowed 2 wires to touch here. Let's see. It's a wire and a terminal, in fact. Yeah, they're shorted there, so shame on me. Let's pull that off. That was grounding. So that was grounding. Interestingly enough, it's not. It's grounding a terminal with a wire to it. Okay. Hope I didn't do more of those. It's very hard to see that one, by the way. Same kind of thing. I'm looking down on something that's standing straight up. It's hard to see something like that. It's like looking straight down on the CN Tower in Google Maps. It's actually hard to see. Power's off. Could be a little voltage on this. Just left a lead wire here I shouldn't have. It's just out in space though, it wasn't doing anything. Okay, might as well clean that little piece up there too. Okay, now remember there was a hum and then the hum went away. I don't think it's a good sign at all. Okay, we're going to apply the power again. There we go. Now, I turned it off because I could hear something making a sizzly sort of sound. And I don't know where I was hearing that from. Okay, that could be everything from something cooking to some electricity tracking over a surface. No, I don't see anything. Let's try it again. Let me get in here a little closer this time. Hey, you know what? Why don't you come in real close? Come on in real close. If something's going to explode, you get a good look at it this way. See, that's a little too close. Too close for comfort. How about... Why don't we try that? There we go. Now, everybody quiet. I'm going to turn on the power. I thought I heard it from over in this area, but I really didn't spend time to dwell on it. Okay, here we go. I think it's tube quivering. You know, tube elements. Nothing bad happening over here. Seems to have stopped now. So I think, you know, that's just the tube elements quivering as they heat up. Let's go back and we'll test these voltages again. Or these lack of voltages. Okay, first, checking the meter. Yeah. Blowing up the meter first. First step, blow up the meter. Okay, here we go. Okay, meter's working. Back on this tube here that was showing us nothing. Hey, this or that. That's usually the grid, I think. Pin 1, 2, 3, 4. What was that? Did anybody see that? I don't know what that was. I'm just getting zeros on everything. There's something. 104. Huh? Oh my gosh, I think I see another short. Oh, I'm a bad boy. Power's off. I think I short between there and there. You know what? I may be working in low light stupid. Might be the best way to describe that. Hey, that's a stupid idea. No, it's not shorted. It's really close though. Hey, wait a minute. Wait one cotton pick a minute. That's not a short circuit, that's a circuit. Okay, wow. I'm still working in low light. Only the problem is now. There's nothing wrong there. So what are we finding out here? Let's just think about this for a minute. We're finding out that there seems to be a lack of voltage on this tube here. And It sure seems to be. I have no end to that sentence, by the way. It just sure seems to be. There is a capacitor down there I left in, right there. But it's not the kind you expect to fail. What monkey business has occurred here? I did test the tubes and replaced 2 of them. One of them was a 6AT6, and I replaced it with a 6AV6. It was a slightly different specifications, same pin arrangement. Huh. Look at that. Okay, I'm not blind. I can see pretty good, in fact. I think I gave the speech on always suspect your own work. Look at that. So, the wire broke. That'll never do. That would silence the radio, that's for sure. So, let's fix that. And exactly how and when that happened, I don't know. I suppose I could always watch back the video on me doing this part and see if I can spot the actual mistake. Yes, I am my own worst enemy many, many times here. Okay, so we'll tack that on there. Well, actually, it's not going to be. I guess you would call that tacking. Maybe the let's just do that. Oh boy. No, that's not good enough. Got lots of solder on the wire, but I didn't heat up the lug enough. There we go. That's good. Yeah, I'm sure somewhere in one of my videos I preached about inspecting every one of your connections after you make it using a magnifier, and guess what I didn't do on that one that I just fixed? I guess I never really inspected it. And it's always the ones you think are good that aren't. Hey, let's try the radio again. Take a good look at my camera here. See what's metal on it. That's metal. There's a front grill, a ring on the front of the camera. Decorative. If the camera drops into the radio, that ring will hey, how about this? That's a little strange. So there I cannot show you a side view of the camera. It's not particularly possible. But anyway, There's the camera in my hand. Falls. Was just pondering for a moment. Wait a minute. What if this camera falls in? It looks like it's got a metal ring on the front. No, it doesn't. No, it does not. Okay. Ready for switching on again. Safety check. Everything's good. Fire on the power. Okay, nothing much happening. Let's turn up the volume. I don't hear a thing. Well, there's a hum in there. Turn down the volume. Switch it over to phono. I think this is phono. Volume down. I think the volume's down. That's not very reassuring, is it? Well, no great ideas are coming to mind here. First, maybe I don't have it on phono. Maybe I had it on shortwave. Let's go the other way. Okay, control is the other way. There we are. So that's the audio section working. I've had a number of radios where the only problem, or one of the problems, was actually the wafer switch, and you know, it doesn't sound like it's not working, but in fact sometimes they aren't. We have the antenna connected. We haven't got a thing coming out of it. Well, I shouldn't say that. I mean, there's a bit of a hiss coming out. Okay, let's do a little poor man's signal tracing here. That's interesting. What's going on there? .300 volts there. A solid 300. Well, it's coming right off the of there. 306. 295. It's not much. This is a 10K resistor. There's not much current flowing through it. Okay, we better give it the full voltage here. There we go. That made me jump a mile. Ay, yay. Ay, ay, ay. Okay. You know, just when you're listening carefully. Kapawi. Okay. What's the B plus now? 360. 330. That's pretty darn high. That works. That was an IF. This side 343, and I'm sure it's 343 on the other side. I'm not going to bother reading it there. Now that's coming out loud and clear, and there isn't a hint of hum. Well, there is actually. Yeah, there's a fair bit of hum. We'll have to quiet the hum a little bit. But that's not a big problem. That's for sure. The big problem is we're hearing nothing. Well, you know, I could try ramming a signal. Yeah, why don't we do that? We'll put the IF signal into it here.